Okay, let's go ahead and get started. Thank you everyone for joining. It's really nice to see you. So today I'll be giving a talk on an introduction to ggplot2. And right off the bat, I want to tell you, I can't teach you all of everything that's in ggplot2 in an hour. So if that's where your expectations were, we need to bring them down a little bit. But what I can teach you are, I think, 3 of the most important ways you can use ggplot2. And the ways that I conceptualize those 3 important ways are, there's the basic ways that you use ggplot2, which are just, you take it out of the box and you feed your data in and you make a pretty basic kind of visualization. That's the first way. Then the second way is you use the extensions that are out there to ggplot2. You use all these wonderful packages that have come out that allow you to make more sophisticated plots more quickly. And so they help automate adding aspects to your visualization. So we'll talk about a bunch of different kinds of extensions to ggplot2 and how you might get started using those. And then the third way is really to use it programmatically. So there's writing your script, there's writing one single ggplot2, and then there's going and taking it a step further and writing functions that make ggplots. Writing a function that helps you make a ggplot can help you make a large number of plots quickly in a standardized format in a way that helps you reduce the introduction for the potential of human error. As in, writing a function helps you decrease the amount of times you copy and paste your code and then fiddle with line by line the copied and paste version. So we want to avoid copying and pasting. There's a phrase out there called dry, don't repeat yourself, DRY, dry. So we want to avoid copying and pasting. We want to avoid potential to introduce human error. And we'll talk about how you can use functions that create your visualizations for you that help you automate that data visualization process. So let me go ahead and share my screen and we'll get started. Okay, so this is a pretty empty R project that I just started. I'm going to start an empty script and we're going to walk through everything from the beginning. The first thing that I want to get going with before we get into the nitty-gritty details, I want to provide you the resources for how you can learn more, because just like I said, I'm not going to be able to cover everything today. So let's cover the resources that are the links that I think you should definitely have. And I'll put these in the chat in a second and I'll bring them up too. So the first is the ggplot website, which I want you to note that it has a cheat sheet on there for you and it has several examples. So let me close out of my email and then make this bigger. So this is the ggplot2 website. And if you go here, it has an overview. It has this really helpful cheat sheet that once you start learning a bit about ggplot2 and all the things you can do with it, referencing this cheat sheet is going to really help expand your knowledge around what the possibilities even are, because there are a lot of great things built into ggplot2 and you have to learn that they're there to be able to use them in the first place. So this cheat sheet is something I really highly recommend. And then they also have a few examples, and you can also check out the gallery that they have, which is a really helpful resource for, I think, generating creative ideas about all the different things that you can do based off of ggplot2. And all of these have code examples, so you can see how you might actually get yourself to a point where you can make something like these. So that's the ggplot2 website. Then I want to point out there's this wonderful article that Cedric Schrerer wrote in 2019 that I think is one of the best introductions to ggplot2. And this one, I think this introduction that he has here, it's more detailed than what I can go over today. And it goes through a lot of the specific nitty-gritty settings and details that you might want to hear about. I'm really going to be giving a pretty high level picture, and this gives something more comprehensive. So I want to put this in the chat too. And then the last resource that I want to make sure that you all have is the R for Data Science chapter on graphics for communication. So the R for Data Science textbook, if you're not familiar, is this really wonderful reference written by, oh gosh, I'm going to forget the second author, Hadley Wickham and Garrett Goldman. So they wrote this. It's free to use. It's all online. And if you go down under the last chapter section, there's graphics for communication, chapter 28. And that goes through a lot of really useful examples on how to get started with ggplot2. So if today is not enough, then here are some resources for how you can go further. Let me make sure that these get into the script so that you can have them forever. And I put them in the chat already, so. Okay. So before we get started, I want to talk about the conceptual framing of what even ggplot2 is a reference to. What is the GG? What is that all about? GG in ggplot2 stands for the grammar of graphics. And I'm going to open up this image that I think is really helpful in describing what the grammar of graphics is all about. And so these are the different layers to a data visualization. I'll provide the source for where I got this image from in a minute, but this image is describing how in the grammar of graphics system, the foundational layer, the layer that you can't do anything without in a data visualization, is the data itself. And so ggplot prioritizes that. When you go to write a ggplot visualization, the code for it, besides declaring that you're about to write a ggplot itself, the very next thing is the data that you feed into the ggplot. So it's about harmonizing what is truly foundational in terms of you can't make a data visualization without data, and also prioritizing it in the syntax so that the data is the first thing you specify in the syntax for a ggplot. And then there's these other components to a visualization. Aesthetics are about how we map the data onto visual features in the plots. And so aesthetics can be things like how the X variable gets formatted, or how the Y variable gets formatted, or how color is specified. What variable informs that? So if you want to make a heat map, you might be saying that you want high colors to be where there's some high density of some variable, or something like that. And that's an aesthetic type of description. That's an aesthetic statement. You might also specify, like in a point cloud, the X and Y variables are coming from what variables from your data set. Those are aesthetics specifications. Then there's the aspect of it, which is what kind of geometry you want to use. So the geometries can be lots of different things, but they're basically the ink on the page. So the aesthetics are saying how you want to go from your data to a visualization. The geometries are what put the ink on the page using that information. So those are things like, I actually want to I want to plot points, like a scatter plot of points on my page, or maybe I want box plots for something kind of scientific, or maybe I want like a histogram. Those are all kinds of those are all geometries that we use. There's also geometries like you might want to plot lines or line segments. Those are all geometries. Those are the ink that gets put on the page. Facets help us break apart our data into essentially multi-plots, repeated grids of the same geometries, but faceted by some kind of variable. So we group our data according to a specified facet variable, and we'll show multiple visualizations with the same aesthetics and same geometries, but for different subsets of the data, depending on the faceting variable. Then you'll see that this also has, moving forward in the upward direction, you'll see it, this is mentioning statistics. Statistics are something we use in ggplot, they're often called like stat layers. The stat layers help you summarize your data I don't want to say automatically. They help you summarize your data before it's plotted. And so you might use a stat summary function to plot the mean of a group, or to plot confidence intervals of a group where your data aren't already summarized when it's going into the visualization. So that can be really useful when you want to plot like a point cloud or something, and then you want to plot the 95% confidence region. Well, you could use a stat summary layer, a statistics layer, to plot that 95 confidence statistical summary information. Then you'll see the last two are really about describing how the plot looks. The coordinates are just like from your like high school and college math classes. This is talking about you can put things on polar coordinates, you can put things on log transformed coordinates, you can change your coordinate systems in all kinds of ways that can be useful or can make your plot worse. You have to be a little bit intelligent about how you use them. But if you're working like with cyclical data, it totally makes sense to have a polar coordinate plot. And then finally, the theme information is stuff like what font is being used for the titles, where is the legend positioned, what color background does the plot have. So the theme really helps you give the data visualization some kind of visual style. So if you work at a major publishing kind of company, like if you work for The Economist, well, they have their own, visual design that they want to use certain fonts, they want to have all of their plots have a certain background, and all kinds of things like that. They want their lines to have a certain amount of weighting. All of that type of stuff gets specified in the theme. So all of this is grammar in that it's the different layers and the order in which we tend to specify features of our data visualization. So this is really the background information that you need to know in order for the organization of the syntax of commands in ggplot2 to make sense. So I really wanted to cover this before we just dove right into examples. So let's get started with coding. So, Todd, you have a question.
Real quick, could you zoom in a little bit on your screen to make it the text a little larger?
Yes.
Please. Thank you.
That's better, right?
That's beautiful. Thank you.
Okay, great. Okay, so I'm going to start with a dependency section. And for right now, I'm going to say we need to load. I actually think for today, let's just load ggplot2. We could load the whole tidyverse, but I don't think we're going to be using a lot of the other packages from the tidyverse. And I'm going to use the Palmer Penguins dataset. So if you haven't installed these, then you'll want to do like install packages ggplot2 like that, and then same thing for Palmer Penguins. So let me just put these. Okay. So let me load these. And I think just to be really clean, you want to have like a data penguins command somewhere in here so that it actually loads the penguins data set into our environment. And let's just take a look at the penguins data set to remind you guys what's in here. So this is a data set. I think we could look at a help page too. So it has 344 rows, 8 variables. It's describing some observations from some penguins from a few different islands in the Palmer Archipelago, Antarctica. So the islands are Biscoe, Dream, or Torgerson. And it has measurements on them like their bill length, their bill depth, their flipper length, their body mass, their sex, and the year the observations were taken. And these are the citations for where the data originally come from. So it looks like the data come from about 2014, or I guess the data were collected 2007 to 2009. So this is a nice data set to use because it has a fair amount of quantitative data and also categorical data like the species and island and sex that allow us to plot the data in a variety of different ways. So it's just an example data set that we'll be using today. It's not the most, like, I don't think you're going to come away with this like, oh my God, I didn't know that about penguins, but I think it'll be interesting nonetheless. So let's start with what I think is probably the most basic type of plots. Let's do scatter plots. In order to declare a ggplot, the first thing that you do, you write this ggplot command. So if you just run ggplot, this is going to return like a totally blank plot with nothing in it. This is just like empty plot. The first thing that you have to do is you have to specify the data. And so that's the first argument. You can either specify like with data equals, or you can just specify the first argument to be your data set. So once you do this, now actually, like if you run this, it looks exactly the same. Nothing changes. But now R knows that this is the data set that we're going to use. Next, we're going to start defining aesthetics. And we do that with the AES command. So if you want to be like particularly careful, the argument name to ggplot for the aesthetics is mapping, but R also knows, or ggplot know, that if you're specifying the second argument with this AES command, then you're specifying aesthetics. So you don't need to specify like data equals or mapping equals every time. R will assume those if you specify the data in the first argument and the aesthetics in the second argument. So I want to make a really simple plot first. I just want to plot the bill length versus the bill depth of these penguins. And so I'm just going to specify the column names, and let's show you what that does. So now you can see, like, I still don't have much, but I have a little bit more. I have X variables specified and Y variables specified. And you'll see I'm also getting shown some axis labels that represent like the data range, but I haven't specified anything about how I actually want to draw the data. And so that's where we added geometry. So far we've added the data, we've added aesthetics, and now we're gonna add a geometry layer. So for that, I'm just gonna specify I want a geom point layer. And you'll see that this is giving me a warning message because 2 rows contained missing values. That's totally normal. That's saying that in these observations, there's actually missing values. So nothing wrong with that. That's actually helpful. So let me save this script before I get going too far. So, okay. So now I think this plot could be made more interesting right off the bat. What I think would be ideal is if I could see something about, you know, which penguins are which. And the way I'm going to start doing that is I'm going to do something, basically just an improvement on this. I'm going to add specification for the color, and I'm going to map that to the island variable. And then I'm going to map the shape variable to species. And we'll run the same thing. And let me explain a few things that are happening here. So first of all, you want to take note that like other places in the tidyverse, you don't need to quote your data variable names. So you'll notice that like here I'm specifying like bill length, bill depth, island, species. All of those are unquoted. So, you know, if you're used to writing like, you know, you normally in other contexts outside the tidyverse, you have to use quotes like that to reference the data. You might use like the $ syntax like this, but usually that's, let me write this out. You write out something like this with the $ syntax, but usually if you're specifying the variable name, in lots of other contexts in R, you have to quote it. So that's often not the case in the tidyverse. So just take note that you don't have to quote these variables. And in fact, if you do, then ggplot will think, it will misinterpret what you think. So like, for example, if I put quotes around island, then actually they're all going to come out the same color because the data I'm specifying is that like, I just want color to be the vector island, where island is just the same for every penguin. I actually want the variable island. So unquoted, I want to reference that variable inside. are. So this is starting to tell me a little bit more information, but it's kind of difficult to see. It's kind of difficult to read quickly because there's just so much going on at once. And so the next thing that I would do if I were like really trying to understand these data is I would start using one of the facet functions. So if we go back to our grammar of graphics, I want to tell you right off the bat, you don't need every single one of these every time because ggplot assumes sane defaults. So the data, you do kind of need the data every single time. You do kind of need to specify aesthetics every single time for those to be useful data visualizations. Same thing with the geometries. The facets though, the statistics and the coordinates and the theme, those all just have totally sane defaults. So I don't have to specify every single one of these each and every time. This time I'm gonna use some facets and show you what that looks like. So there's two facet functions. There's or I guess there's three. I don't know about what this facet null does, but facet wrap and facet grid are the ones that I'm using all the time. So I'll just show you what facet wrap does. Facet wrap and facet grid take a kind of interesting syntax. You have to specify what's called a formula syntax in here, meaning you need to use the tilde operator, this little squiggly line. And if facet wrap lets you facet with just one variable. So if I facet by species, with species on the right-hand side of this equation, then you'll see that I get a plot for each of these species. And I could change it up. I could make the facet wrap for island instead. And I think this plot is actually really interesting because now you can kind of see that Biscoe Island has two different populations. It has both the Adelie and the Gentoo penguins. And then same thing with the Dream Island that has Adelie and Chenstrap penguins. And so we're actually starting to learn things from this, whereas I couldn't really quickly read the prior plots. They were a little bit too dense for me to just immediately understand what I was seeing. This is starting to help me understand the data a little bit because I used this facet wrap that helps break apart the plot into smaller pieces. The other thing that we could do is, let me show you how facet grid works. So facet wrap will basically just wrap your variables as is convenient. Facet grid is a little bit more specific. It says that I specifically want this variable to go in the faceted rows and this variable in the faceted columns. So I could specify, for example, faceting I think this is the rows by the species and the columns by the island. So now I'm seeing the data, again, a little bit more stratified, and I'm specifying exactly how I want them to be faceted. I could put the same exact thing into a facet wrap, and you'll see that it does things ever so slightly differently. It's going to do two things that are really different. One is it wraps. It doesn't just like have a grid. And the other thing is it's dropping the plots that have nobody in them. And I think that's a default behavior that you can change. But I guess the final thing that I'd want to point out is because facet wrap doesn't specify the variables going into the columns and rows, but rather just wrapping each group, you're seeing that both the left-hand side and right-hand side variables are getting put in these facet headers right above each other. So the format is just a tiny bit different. And we could actually like keep adding variables. We can we can add the penguin sex into this, and we'll get more facets, and it'll get difficult to read. Yeah, but you can essentially keep going with this. Come on, it's rendering. There we go. So, this is showing me my data like a little bit more stratified than I'd actually want to see it. I kind of prefer the prior plot or the prior two plots where I was just faceting by species and island, but this one has sex in it too, and you might be interested in that. So, okay, let me talk about something else you might do. If you're interested in science, you might want to add a model to your data, and you might want to quickly see if there's some kind of model that you're interested in. So what I'm gonna do is I'm gonna take, let's take one of these facet wrap scatter plots, and I'm gonna add a slight improvement to it. So we're going to add this, and we're gonna add another geometry to it. So let's just add this geom smooth layer. So this geom smooth is saying I wanna specify some kind of model for the data that smooths the data, and add that on as a geometry. And so you can see we're getting these like, what these are defaulting to are, it actually tells you it's using method low s and formula y regressed on x. That's fine, that's pretty much what I wanted, except the low s, I can't remember what it stands for, but it's basically giving you smooth splines. Like these aren't linear regressions, these are a little bit fancier. I actually just want linear regressions because I don't, these look a little bit too wiggly for me. Maybe for whatever reason, the group I work with or something like that, like for whatever reason, you might want a linear model. So you can specify method equals LM, and you can see now we have linear models, which are much less wiggly, much less distracting kind of. And so if you wanted like one slope for each of these groups, this might be one way to get that. You can specify a whole bunch of arguments to geom smooth. You can tell it that you want these standard error confidence intervals on or off, but I don't want to get like totally bogged down in the details of that. Let me say one other thing about this, which is it's a good time to say you can specify different aesthetics for each geometry. You can actually specify data and aesthetics for every single geometry. So for example, let me first show you, like, you could do this same plot, and instead of putting this here, you can put this in geom point. And let me just turn this off for now. And you'll see that this renders, oops. Okay, so the thing about these is if you put the data into the geometries, you actually do need to specify the argument names each and every time, because the geometries are assuming that they're getting mappings as their first argument. And I'll talk about why that is in a second. So this is our plot from before, and maybe we want to do something slightly different with the geom smooth. I'm gonna put this back in the original ggplot because I was just doing that as an example. And what I'm gonna specify is that I actually, like for example, maybe the groups that I want, I actually just want these to be by island. And so if I specify this, you know, it still might stratify these models because color and shape are different. Let me see what this does when I put group. There we go. Yeah. So the linear model now knows, like, I wanted to group just by island. So whereas before it was assuming the same, it was assuming the island based off of color and species, based off of all these different aesthetics. Now, because I'm specifying the group explicitly, it knows I just want island. And I would kind of say this is a worse model because it doesn't respect the fact that these are two different species and have a different, this is a bit of a Simpsons paradox thing kind of going on right here. But nonetheless, you might want to specify sometime an aesthetic in your geometry. And this is how you would go about doing that. You just put the AES command at the beginning of your geometry, and it will inherit the same data, and it will inherit the aesthetics from the ggplot command, just like every other geometry does. Like this geom point inherits all of these aesthetics from the ggplot command. But if you want to change any of them, you just specify aesthetics, and then you specify whatever aesthetics you want to change. Okay, so that's a bit about adding linear models. Let's see, what did I want to add next? I wanted to keep going on this concept of adding layers. So maybe these linear models are like not doing it for us. Like, okay, yes, they tell us about the slope of the relationship between bill length and bill depth, But maybe I actually don't want to know that information. Maybe instead I want to know something more like, what's the most common like bill depth and bill length? So for that, I would want something slightly different. Like maybe I want some kind of heat map, or maybe I want, for example, like we might put, let me see, what did I want to put? I think geom density is one good option for that. And so this is going to show us contours, where now you can kind of see the modal values for each of these groups. And so this is one option you could do. There's lots of other options, like instead of doing this geom density 2D, there's also like geom hex is really popular in some crowds. And that will show us something. Oh, that's kind of terrible. Let's see, what happened? Oh, it's because the color is specified. Let's not talk about geom hex right now. You can learn about geom hex on your own. I really wanted to show you the contour lines from geom density 2D, because I think those are actually useful, and you might enjoy using those. And my point really here being, you can layer the geometries. Like you don't have to have just one geometry. You can add like a geom density 2D layer and then geom point. And what you should know about adding geometries is that basically they stack on in the order that you add them. So here, like the points are on top of the geom density 2D contour lines. So like if I want to override the color here, I can, like specifying this outside of an aesthetic, and then you'll really be able to see that the points are in fact on top of the contour lines. Like we don't see the lines going over the points, we see the points going over the lines here because of the order, because geom point comes after geom density 2D. So I wanted to make that point about the ordering mattering and the order that you add on these geometries. So this is the ordering I like for this. Okay, another kind of plot that I would think you should know about are like bar plots. These are another really simple plot that you are probably going to want to make at some point. So I'll start with a really simple one. Like I just want to see the counts of the penguins by sex. So here's the breakdown. It looks like we have like, I guess about 160 or 170 females, and then a little bit more, like maybe 5 more males. And then we have a bunch in this NA category. So that was helpful, quickly summarizing the data. And maybe I want to do things really similar to what we had already done in terms of stratifying by species. Like maybe I want to change the breakdown. Maybe I want to see the data by species. So you might try to use color or fill to do that. Keep in mind, color and fill are slightly different aesthetics. Color typically, like color for points is the color of the points. But if I specify color here, I think it colors the outside edges, which is not usually what I want in a bar plot. Usually I want the fill to be colored in the bar plot. So that's why I'm using fill for species here. And I didn't really want these stacked on top of each other. So I'm going to change the position argument in bar. So I'm going to change it from its default is stack. I'm going to change it to dodge. So now I get, this is a lot more like the plot that I actually wanted to see. These are dodged in each of the species groups. The x-axis is the same, like it still goes female, male, NA. But within each of these levels of the x-axis, they're dodged next to each other. So instead of stacked on top of each other, they they're dodged. I don't really know another good word for what dodging is, but basically it puts them next to each other. And then maybe the final thing that I'd want to do is maybe I want to actually break this apart by species or something like this. And like in this example, you might notice that I've used species twice, like I've used it in the aesthetic and in the facet wrap. I don't think there's a problem with that. Like sometimes just having the color in the visualization, even if multiple aesthetics are referring to the same variable, sometimes that just helps communicate the data. I wouldn't think of it as being duplicative. This actually, like if I take away the fill, it's just kind of a more boring plot. And I mean, there's times when you maybe want the more boring plot, but you know, I like the color essentially. So do with that what you will. Okay, let's do box plots because those are like a really common statistical scientific kind of data visualization that I think a lot of people are probably interested in. So you specify a variable. It can actually be either the X variable or the Y variable. If you specify the X variable, your box plot will be on its side. If you specify the Y variable, your box plot will be upright. So it's a matter of taste, which one you want. I typically go for the, actually it depends. It depends on the context. So I won't make any like overarching statements about which one I think is better. But you can use the X variable to like stratify. So like maybe we want, like one thing that I would actually imagine is that there's probably sex differences in the penguins' body masses. And indeed there is, like there's the male penguins weigh a little bit more. I'm not surprised. And then, you know, we might keep going. We might put like fill is species so that we start seeing things a little bit more broken down. And now you can see that like the Gentoo penguins weigh a bit more than the other Adelie and chinstrap penguins. And then the chinstrap versus Adelie penguin relationship is kind of interesting. Like the male penguins weigh a little bit less than the female. Or anyway, I don't want to spend my time like interpreting these penguin plots, but you can make box plots. It's pretty fun. They'll teach you things. I think you might also, you know, it depends on your taste. Box plots aren't like everything. Some people like violin plots, which are kind of like density plots. So I'm going to specify all these same like data and aesthetics, and I'm going to specify G on violin instead of G on box plot and show you what that looks like. So these are little like blobs that represent the density. Instead of having like the median marked off and like the interquartile range and the whiskers like in box plots, these are actually showing us a smooth density estimate for each of these groups. And a lot of people really like to combine box plots and G on violin because if you specify like the width to be a little bit small, you actually need to specify also the position to be a little bit specific because of the defaults that are being used in G on violin. But I think if I do it like this, we will get box plots on top of our G on violins, which can be really nice. Like this, I like this. I would like it a little bit more if like, I'll keep adding things. Like I like a little bit of transparency and a little bit, I like the, actually this should be fill, not color. Oh no, I messed up. Let's see, I think I need to keep the aesthetic group to be species. And then I'll be able to specify the fill as white. Nope, I messed it up. Never mind, let's not talk about it. So I was trying to make the fill color in each of the box plots white so that that would have a little bit more contrast against the color of the G on violins, but like, let's not worry about it right now. I mean, you guys and I can figure out how to do that later. Another thing that I really like in terms, just going off of these box plots, I really like using jitter in my box plots, behind my box plots, because let me just go ahead and copy. Let's see, I want that much of this. I think I'm going to need to specify a little bit more. So those jittered points, I need to make sure that those also get position dodged. There's a special kind of dodging that you want to do when you're doing jitter. You want to use the position jitter dodge function, because it's going to both dodge, as in put them side by side, like the box plots are side by side. And then it's also going to let you specify how much jitter or how much noise is added to your data. And so, okay, now we're getting somewhere. I want the color on this to be, I want these to have black outlines. There we go. I kind of like that. And I'll add some transparency, so that, which is specified with the alpha parameter, so that I can see the jittered points behind my box plots. And now this is kind of nice, because if you didn't trust the violins, if you thought that like, what are these blobs? They don't look very scientific. Maybe you trust like the jittered points and the box plot summaries on top of that. Maybe you feel like, now I can see it with my own eyes a little bit, like what the distribution of the data is. I really like this because it feels like I'm showing you both some aspect of like the raw data with like a little bit of noise added. And the reason for the noise is because I can actually show you, like if I put a geom point here, they'll all be on top of each other. So I will have to put a position dodge, and then I think all I need to do is just use the defaults for position dodge. If I put this without the jitter, you see the points are all on top of each other. And I don't know why the dodging isn't working right, but I mean, oh, oops. So that jitter is, I don't know why they're not. Let's see, do I need to put this? No, I'm not sure what I need to do to get the position dodge to work with geom points. But the problem is essentially shown here, where the jitter helps you get them all off of being on the same line. So once you use like geom jitter, then they're not all on the same line, so that you can actually see their distribution a little bit better. Robert, you're asking a question. Is there a way to jitter in relation to local point density? Yes. So you would want to look into, it's called geom Sina. I'll put it in the chat so you can look it up yourself if you're interested. We can talk about it later. Okay. So I think at this point, like there's a couple more, you know, things I could keep showing you. Like I could keep showing you like how to add the labels to your plots and how to add like themes and things like that. Let me show you the labels, but otherwise let's get moving on to extensions. So like let's take this plot that I have right here and let's improve it a little bit by adding an x-axis, a y-axis, and a title that I actually like. So maybe the x-axis was fine, I just want title case. The y-axis, like that's not really professional. I want title case and I want the units to be in parentheses. And then I want like a title that spells out what we're looking at. So I might add this labs, short for labels command, with these arguments for each of these aesthetics and the title. And now you'll see like my plot has better labels on each of the axes. I can actually also add for the fill in the color. Like maybe I wanted that in title case too. So I want these. And now you'll see that over here, my legend is also title cased. So, you know, some people will tell you like you have to have a title on your plot. This is how you do that. You can add the title in labs, or another thing that you can do is there's the gg title command. So if you wanted to use gg title, you can also specify the string here and that will turn into your title. I kind of like using the labs command because then all of your labels are in the same specification in your ggplot code. Okay, so now, before I move on from the basics of ggplot2, there's one last thing that you really, really have to know, which is how to save your plot. So you've made your beautiful plot. You think it looks really pretty on your RStudio viewer screen. Let me make the version that has the title and legends that I want. You want to use this ggsave command. And you can either specify the plot argument here, or it assumes the last plot that you rendered is the one that you want to save. So in this example, I might do that, and in which case I just specify the file name that I want. So I'll specify, I'll just call this like body mass, sex, and species PNG. And it will automatically assume based off of like this ending, like I can change the file ending and it will automatically do its magic and render like the file type that I specify. So you can put like PNG, JPEG, PDF, whatever. And then if we go to look at our files, you'll see it's made them and I can open them. And here's that plot, like all rendered as a PNG file. Here's the PDF version. Like in case you wanted the PDF version, which can be useful because then you can pull it into like Illustrator or something and turn it into like a really pretty infographic if you want to keep polishing your visualization in like another software. So it supports lots of file extensions. Another one is like SVG for a vector graphics file. But yeah, ggsave is the function you want to save your ggplots. Okay. So let's move on to the second of the topics that I wanted to cover, which are extensions to ggplot2. And there are a lot that will make your life easier. Let me just write down a bunch for you, just so that you have a list to check out at your own discretion. And I'll focus on a couple of these. Let's see. Okay, I think that's a good list that covers a lot of the ones that I find myself using these days and that I know are pretty popular. So the ones that I want to focus on today, as long as we have some time, are ggRepel and patchwork. So ggRepel solves an interesting problem. I know we're mostly working with the Palmer Penguins data set. I want to use the MT Cars data set really quickly to show this example because the data lends itself a little bit more because every row has a specific label. And before I start writing this ggplot command, I'm actually going to do a small transformation. So I do want, okay, so for this section, I'm going to library the tidyverse because I'm going to do some data manipulation with dplyr from there. And I'll go ahead and library ggRepel since I'll use that in a second. I'm going to do a mutate step to, or sorry, not a mutate step. It's from the Tibble package, the row names to column, and I'm just going to call the column name. So this is the name of the car. Annoyingly, this data set comes with row names, which aren't a column. They're just row names. And so to actually make that into a column, like a variable, like a normal variable, you can use this row names to column. And then you'll see that these are in their own column called name, like name of the car. And this data set has like MPG, cylinders, engine displacement. So you can transform your data, like as in other tidyverse functions, before you pipe it into ggplot2. So you can pipe into ggplot, and then I'm going to specify, like, I'm curious about the relationship between engine displacement and horsepower, for example. So I'll specify those in my aesthetic, and I'm going to plot it. This is all just really normal stuff so far. We've covered most of that. Now I'm really curious about some of these, like what are the outliers? So what I might do is I might add a label aesthetic. So I'll specify the name is the label that I want, and I'm going to add a text geometry. And it kind of is going to look terrible because the text is getting plotted exactly at the same spot that the points are being plotted. So it's like kind of close to what I want, but I don't actually want like the same X and Y variables. And I could try and fix that with like I could try and have like perfect like left adjustment. And I think that, because right now they're centered, left adjustment helped like a little bit. I could probably make it even a little bit better with like a little bit more left adjustment. But you see the text is still overlapping in tons of places. So instead of using geom text from the regular ggplot package, I'm going to use geom repel text. And this does magic. Like, let's see, what did I not library gg repel? Maybe I got the function name wrong. Gg repel, geom text repel. I think I had it spelled wrong, like geom repel text instead of geom text repel. Now, this actually like pulls my labels away from the points so that they don't overlap. They don't overlap with the other labels and they don't overlap with the points. And if they're far enough away, it draws a little line so that you know which one that they map to. This is magic to me. I mean, I know that it's a pretty simple like optimization to actually like do the magic that's under the hood, but this saves so much time when you're trying to like be really nitpicky about getting things labeled on a plot in a way that they aren't like impossible to read. So GG repel, it can be really helpful. It can really help you with labeling your plots. So it can do more. I don't want to talk too much about it, but I want you to know that it's out there and that it's really, it just helps. It basically implements a few more geometries that aren't built into ggplot. So you just use those geometries in your ggplot code. It's really easy to use these extensions to ggplot. So the next thing that I'm gonna want to show you is patchwork. What we can do is let's go back to our example with the Palmer penguins data set, and let's make two plots because I want to show them side by side. Like this is a common thing you want to do in scientific manuscripts. Like you might have plot panel A and plot panel B or something like that. So I'll just make really simple plots for these. I'll specify the penguins, and then maybe I want a histogram of their body mass. And for the second plot, maybe I want their flipper length histogram. So now we can look at each one of these like on their own. Apologies, I only flashed it for a second, but that was the body mass one. Here's the flipper length one. They're histograms. They're not like anything spectacular. Once you library the patchwork package, it allows you to do this really interesting kind of, just like we've been adding like geometries and layers to our ggplot2 objects, patchwork allows us to add our ggplots together. And when we add them together, it adds them together into a combined layout. So what this will render is a side-by-side of the histogram for body mass and the histogram for flipper length. And I'll save this as an object called patchwork because I want to keep doing things to it. I'm gonna do two more things. I want to add an annotation. So I'm going to add a plot annotation for title first. So just to put like a title above the two different data sets. And then the other thing that I want to do is I want to put tag levels. This is something you really have to do quite often if you have if you make scientific manuscripts. So like I want A and B to appear next to each of these panels, and this will automatically do that for me in this plot annotation. So now I can reference like panel A, panel B in like the caption to like my scientific manuscript or something like that. When I like write the legend or the caption for this. And you can keep going, like you can make a 4-panel plot. And let me actually show you how you would do that. For right now, just for the sake of saving time, I won't make new plots. I'll just reuse plot like 2 twice. So just like you did the addition, you can also do division, which, so like addition means next to each other and division means over. So kind of like the fractions metaphor. So I'll just put plot 1 and plot 2 again. So if I do this, I'll get the 4-panel that I'm interested in. And like I might, oh no, let's see, why is it, oh, order of operations, guys. You have to mind those parentheses. So yeah, if you didn't catch on to what was happening, I didn't have the numerator in parentheses, essentially. I wanted like, anyway, I wanted the 4-panel and I had to put parentheses to get them. And so then I could add like the same plot annotation if I wanted. I could keep going. And you'll see that when I do this tag levels, you'll see I get A, B, C, D now. And I could, these could all be different plots easily. So I wanted to show you patchwork because I think when you're making scientific manuscripts that have a bunch of these different panels as one is wont to do, this is really helpful, is the short of it. Okay, so let me get to the final section that I wanted to talk about, which is writing functions to help you with your ggplot code. So I'm gonna write a really, let's see, let me think about, I want to make a density plot for different variables. First, I'm just going to specify, I'm going to go ahead and say that like this function takes any data frame and any variable. And what it's going to do is it's going to make a ggplot with that data, and it's going to specify that variable is the aesthetic variable for X, and it's going to make a geom density. And the really special part here that you need to know about is if you're going to specify the variable in the unquoted tidyverse style syntax, then you need to use these double brackets, these double curly braces here around the variable when you go to put it inside the aesthetics. So let's see what this does. Oops, didn't mean to copy it. I want to actually call it. So maybe I'll put the Palmer Penguins data set, and then maybe I want the variable body mass. So this will go ahead and just show me the density plot for body mass. I can, like, one thing that I want is I actually want there to be some fill on this. That's just an aesthetic improvement. So now it's filled in, but I can change this variable. Like I can make this to be flipper length. And I can also change the data set. Like I could put empty cars here, and I can put the engine displacement variable here. And this is the same function, but with different data sets and different variables being used. And so how might I use this in an actually useful way? Like maybe one of the things that I would want to do, let me actually make like a little bit more complicated of a function. I'm gonna just go ahead and copy and paste it here, and then I'll tell you what it's doing. So I want a function that makes island species stratified histograms. And I'm gonna specify the variable, and I want to specify the label for the variable because I don't just want like body underscore mass underscore G. Like I want something that looks pretty. And I'm going to specify this additional argument whether or not to put the legend. And you'll see, I mentioned before that in the theme, you can specify whether or not where the legend goes or if it goes anywhere at all. Here I'm saying if legend, then put it on the right. If no legend, then put none for the legend position, which is how you tell ggplot to have no legend. And so here I'm assuming I'm going to use the Palmer penguins data set. I'm specifying the variable in these curly braces. I said I wanted these to be island and species stratified, so I'm faceting by island, and I have the fill for species, and then I have these histograms. I'm putting a little bit of transparency. And then remember how the geom bars, they automatically default to position stack. I want position identity so that they overlay. You'll see what I mean in a second. So I'll go ahead and declare my function, and let's call it. So let's call it with body mass, and let's put that here. Okay. So now let me make the proportions a little bit better. Now I have a histogram for body mass. It has this nice x-axis label that's title cased and says the units in the way that I like, because I put the label argument here. I just passed in body mass with no quotes. So then I can do the same thing for like flipper length. And I'll put in the way that I want it formatted in the in the axis title, and I can keep going. So the other ones that I want to do are the bill length, and then the bill depth. And then I'll just assign these to some plot object, just assign them to objects so that I can reference them. And then what I think is actually useful is to go and use patchwork like I was showing you, and we can make our 4-panel plot without having had to copy and paste pretty much any code to do it. Let's see, is this rendering? There we go. Oh, was it just hanging for a second? There we go. So here's like the 4-panel plot that I wanted. There is this little issue with the x-axis text. You just have to like finesse it a little bit. The way that I would do that is I would still use this function that I specified, but I would keep adding on here. The way I would fix this is to specify how many breaks I actually want, because there's too many breaks on the x-axis here. So for plot 1, I want fewer breaks. I want like less than 3 breaks. And we'll re-render this. So now I have like fewer breaks on this, and I don't have the x-axis variables going one over each other. Katya, you have like an excellent point. This is a lot like faceting the way that I've presented it, but you don't have to, they don't have to be like facets at all. So like I could replace plot 4 with something totally different. Like maybe I want the penguins data set, but like maybe for whatever reason, I want a density plot of bill length. So I could specify that like this, and then they could be, you'll see what I mean about the 4th plot is like of a totally different format. And I mean, this can be really powerful because that gives you space to show, like, maybe you show the raw data in panel A, and then you show like one kind of summary visualization in panel B, and then a different kind of visualization in C, exactly, or totally different data sets, comparing and contrasting them with the same aesthetics or that kind of thing. And the trick really that I wanted to show you is that you can use functions to make your ggplots where you're going to make a lot of them, maybe for different panels in a visualization, or maybe just to be able to compare them one by one, pull up 2 side by side on your computer. If you want to make a lot of different visualizations that have a similar format, or just take programmatic arguments, that's something that can really help you accelerate your data visualization and discovery. To format your plot generation in a function like this that takes arguments and then call it with the different specifications that you need, as opposed to copying and pasting ggplot code that's really similar each time you paste it, and then trying to keep track of like, so I changed that one, but maybe I want this change to be like a sweeping change throughout all of them. Now I have to go and like update everyone that I pasted. You don't want to mess with that. Like it's better if you make a function. And then like I was showing here with the scale X continuous, if you not need to modify one, you still have the opportunity to do that. You can still specify like a totally different plot here or something like that. So I really hope that this was helpful. I know I went a little bit over time. Apologies about that. And I'll go ahead and stop and ask if there's questions. So thank you so much for coming, everybody.
Yeah, thanks. It was great.
Thanks, Robert. So yeah, we have been recording the talk. I will post the recording to YouTube and share it with all of you. Yeah, I really hope that you learned and feel like you're taking away resources that will help you with your data visualization.
Hey, Christian, this is Jeff. Will you be sharing the script file that
I will. Yeah, definitely.
Awesome. Thank you so much. This was really super helpful.
Where will you be posting that? In Slack? No.
Yeah, I'll email it to the group. Yeah, I'll post it on GitHub and send you the link to the file.
Thanks.
And this is just to say the last presentation was really great. Like I feel like some of the points in the discussion afterwards were so key. So thank you.
Yeah, of course. Thank you. I'm glad you've been enjoying it. All right. Well, if there aren't any questions.
I've got a question, but
oh, go ahead.
Wait till you're done recording though.
Oh, okay. Are there any questions people want recorded? Okay, speak now, forever hold your peace. Going once, going twice. Okay, I will stop.